Hi, I'm Ford Hallam. I'm a master goldsmith of nearly 40 years' experience, and for the last 25 years, I've specialized in classical Japanese metalwork. In this film, I'm going to introduce the basics of non-ferrous patination using the famed Japanese green chemical known as rockshaw. I'm going to go through the process as I use it in very basic patinating procedures on copper, shakudo, shibuichi, and other non-ferrous metals used in Japanese iroe, that's the colored metal inlay work. The classical Japanese patinating process I'm going to be talking about is also known as niage or iroage. It's a very gentle patinating process, unlike many that seem to develop a crust on the surface of the metal. Japanese traditional patination in this format has been called matrix coloring by at least one Japanese researcher, in as much as the surface layer of the metal is converted to an oxide, but in such a gentle way that it can sometimes reveal the structure of the metal. So this follows then that the surface preparation of the metal is very important. The colors tend to be quite glossy. That is to say that whatever finish you leave on the metal, the patina will have the same characteristics. So if your metal's polished to a mirror finish, your colors will be very rich and glossy. Similarly, like with shibuichi, which tends to have a velvety finish if finished properly, that patina will then also be somewhat velvety. So the solution itself is very, very mild. Typically, a liter of water will have 2 grams of rockshaw and 2 grams of copper sulfate. As I proceed with this demonstration, I'll talk specifically about the ingredients as we get to them and why they are as they are. This green powder is the rockshaw, probably the single most important ingredient and also the hardest to get hold of. There are a number of alternate recipes online and in various jewelry books, all purporting to offer the same results. They will give you various types of patina, but having tested pretty much everything over the last 25 years, I'm fairly confident in saying that this stuff is the only stuff that will give you the authentic colors as seen on antique work. And it's the only stuff that will give you consistent, reliable results. It is expensive, unfortunately. It's about $200 for a pound's worth. That's a pound's worth. Having said that, it does last an awfully long time because we only use a very small amount. It comes in this box. This is as it comes from Japan, a pound's worth. It's made by a company called Soma Industries. They primarily make paint, but they've allegedly been making this for a couple of hundred years. So it's used with copper sulfate. If you've seen any of the recipes in print anywhere or online, you'll be familiar with the proportions of 1.8 liter of water and 3.75 grams of rockshaw and 3.75 grams of copper sulfate. This sounds very specific and very exacting. It's not, in fact. 1.8 liters is a shaw, the very large bottle of sake. So it's just a very large measure of liquid. And 3.75 grams is an Edo period measure of weight called a momme. So the recipe, in a sense, is almost like saying half a teaspoon with a pint of liquid or 2 pints of liquid. So it's not as exacting as it might first sound. Also, as you're using the solution over a period of time, you'll be adding tiny pinches of ingredients to balance the alkalinity and acidity. This is a very, very subtle thing. Don't get excited about that. We'll cover that as we get to it. But the important thing to take on board is that the solution is very mild. What I've got here is 2 grams of copper sulfate, just straightforward copper sulfate, CuSO4, and that's 2 grams of rockshaw. Rockshaw doesn't dissolve all that readily in water, so you'll find that there's always a little bit of graininess in the water, which is why it's very, very important always to keep an eye on your piece when it's patinating, and you keep agitating it so that any residue in the water doesn't settle on the piece. If that happens, your patina will be mottled and have little matte patches and marks, which is, well, unless you want it to look rubbish, don't do that. So here we have the ingredients we need. Tap water is probably not advisable because invariably there's either chlorine in the water or there's calcium carbonate if you're in a hard water area. And what happens is as you're boiling your pot away, lots of water is evaporating and the concentration of calcium carbonate, for example, will build up, and that will eventually start to plate, a bit like plaque on your teeth, will plate onto the metal and is a devil to remove. So I try to use distilled water wherever I can. If you have a dehumidifier in your house or in your washing machine, that's a good source of free distilled water. Alternatively, I buy deionized water from a automotive supply company. So that's what I use. The next thing to think about is the containers. You can do patination perfectly adequately in a heat-resistant Pyrex dish. However, traditionally copper pots were used, and copper pots have the additional advantage that they develop a wonderful crust. Now, I don't know if there's any science behind this. It might just be cooking folklore, but this crust is very similar to the natural rochefort or verdigris. And it seems to actually help with the patina. So a nicely seasoned copper pot like this is very helpful. I have a number of them and I keep them for different concentrations. This is a standard mix I use in here. So into this I'm going to put 1 litre of distilled water, the 2 grams of rochefort, 2 grams of copper sulfate.
Recording.
Right, I've got my copper pot on an electric hot plate.
Okay, stop. Okay, go again.
I've got my copper pot on an electric hot plate. This is what I tend to use for a lot of the smaller scale work that I do. These are fairly inexpensive. They do get a bit wrecked though. Things bubble over, so they're disposable in a sense, I suppose. So I'm going to pop 1 litre of distilled water into the pot. And then I have to get rid of this jug of water because apparently it looks ugly in the shot. We can't have that. And into the water goes our 2 grams of copper sulfate and 2 grams of rochefort. This is like a proper cooking program, isn't it? Well, patinating is a bit like cooking rather than the science. And as you go along, you'll learn little tricks that help you achieve the best results. Right, so I'm going to put this on to get it up to a boil. This is just water, copper sulfate and rochefort. There's one other ingredient that I tend to add at the start, and that's a pinch of borax. Straightforward powdered borax. And literally just a pinch or 2. So this will ensure that the adequate alkalinity is maintained. So that's the basic solution made up. As I say, the rochefort won't dissolve fully. It'll often be a little bit grainy and powdery in the liquid, which is why it's so important to keep your piece moving while it's in the liquid. With the first time you bring it up to the boil or up to a very high simmer, when it's got borax in, keep an eye on it because it tends to froth up and it'll flow over. Once it's had its first effervescence, it tends to be okay. But that's just a word of warning. We'll probably catch it and it'll probably boil over while we're doing this demonstration also. Right, so while the water's getting up to temperature, I'll give it a little stir to make sure everything's nicely distributed, not caught on the sides. Never put ferrous metal or brass for that matter, into your patinating solution. This is a little copper spatula spoon I hammered out. So I use this for stirring, adding my bits of rock show and other chemicals as I need them also. So you can see the froths building up. That is the borax, as I said. So you really have to keep an eye on it. You really don't want it to bubble over. It makes a hell of a mess, and does ultimately ruin your hot plate. So there it is. The other things we need at this point, you need a tub of clean, fresh water. That doesn't have to be distilled water. Regular water will do, so that when you take your piece out of the patinating solution, it needs to go straight in cold water, because if, as it comes out of the patinating solution, it's obviously going to be very hot, the liquid on it will dry and it'll leave a residue. So you really need to get it straight in the water. What I use in this instance, I'm going to use a little sample copper plate with some inlay on it, just to demonstrate the process. This is a little vegetable rinsing bucket that I got in a 100 yen store in Japan years and years and years and years ago. Something like this in plastic, a little plastic colander, a little bamboo woven basket, of course, would be traditional. It's useful because, of course, it goes in and out quite easily. Being plastic, it doesn't really mark the metals. I shall do another more detailed follow-on video where we'll talk about different ways of holding things and so forth. But this is pretty handy. It fits quite nicely inside my pot, and I can keep moving it about. And it goes straight into the cold water, and then I can deal with the piece when it's cooler. The next element that's really very important is daikon. This is the large white icicle radish, also known as mooli in West Indian cooking, I believe. You can buy them fresh if you are lucky enough to live near an Oriental supermarket, or in fact if you live in the Far East. I buy mine sort of a couple of kilos worth once a year, and I freeze them. It's handy if you chop them up beforehand, because they're quite difficult to chop up when they're frozen. So that's a little chunk of a very large one. I find that freezing them works perfectly fine. They smell a little bit. You wouldn't perhaps want to eat them when they've defrosted from freezing, but they're perfectly fine for our purposes. That is, we're going to grate them up, or rather I'm going to grate it up into this tub, add a little bit of water, and once the metal sample that I'm going to patinate, or the workpiece that I'm going to patinate, is ready and it's polished and cleaned, we pop it in the daikon solution for 3, 4, 5 minutes. Not terribly long, just long enough, and it acts as a holding solution. There's an enzyme in the daikon that digests grease, and while the piece is in that solution, it doesn't tarnish at all. So it's a really handy intermediate step. It really is quite critical. I've never had a successful patination without using daikon. On occasion where I've not had daikon, or once or twice I've used regular radish, it was reasonably adequate, but if you can get the real thing, please do. Obviously, pickled daikon is not usable. Right, so I'm going to grate that up, add a little bit of water, keep it in here, and that will go there. So that when I finish polishing, the piece goes straight out of the clean water into the daikon. After a few minutes, it can go into the basket and into the patinating solution. In some respects, grating up the slightly defrosted daikon is easier than grating up the fresh stuff, because it's already quite crystalline. That should be enough. I might as well do the rest of it though. And the little bit that's left over, I'll just chuck in the pot also. Pop it in there. And now to that, I'm just going to add enough water to cover it. So I've got 1/2 inch or 1.5 centimeters of slurry in there. So there we are. It's tap water in this instance again. I'm not overly concerned about tap water for this or rinsing because this isn't going to go into the pot in any major amount. So there's very little risk of building up any calcium or anything like that. Right, so just so you know, we're filming this pretty much in real time. So the pot is now quite warm. It's starting to steam and we've got a nice frothy surface. I'll want to put it down to a simmer in a moment. I'd like you to see it bubble up, but on the other hand, I don't really want it to boil over and make a mess. But I'll see if I can time it just right so you can see. The daikon solution is now ready. The thing with daikon, whereas you can leave it perfectly fine frozen in its solid form, for up to a year as I do. Once you've grated it up, however, you really need to use it in that one session. It's not going to be of any use to you tomorrow. If I were to come back tomorrow morning and try to use this again, the metal will be covered in stains and so forth. So you really do need to grate up a fresh batch every day. That's really, really critical. There are some chemical solutions that platers use as holding solutions and so on and so forth. I don't use them. I've not tried them. I have no interest in trying them. There are enough health hazards with some of the things I use without adding to that. I'm perfectly happy to wrestle with daikon fumes. Right, so the pot's been warming up for the last 10-15 minutes. It's quite close to boiling now. Chances are if I were to go away and do something, I'd come back to find this all boiled over. So it's really critical, as I say, at the first instance, when you bring it up to temp. I can see the surface is starting to shake. There's quite a lot of activity underneath the foam. Foam is getting thicker. I've got some cold water to hand, so I'm going to let it build up, because if this were to happen to you and you weren't expecting it, I don't want you to be all shocked and horrified and think that you've ruined your solution. Right, you can see it's starting to bubble quite actively now. It's at this point that it can all go horribly wrong. So I've got cold water to hand. It's not wine, not yet anyway. So it's starting to bubble and you can see the foam building up. So I'll just let it go on a little bit and you can see how it gets really quite vigorous. Here we go. And you can see how the froth gets nice and big. Oh, isn't that pretty? Right, so now I know the solution is pretty well mixed and I can turn it off and just put a little bit of cold water in to calm it down. Right, so now you've seen that. Once it's simmered a little bit now, this froth will dissipate and you won't have to worry about loads of bubbles getting in the way. Nobody wants to patinate in a bubble bath, do they? Well, I don't know, some people might. Right, so that's ready to go. I would never put something into patinate until I'd done this process. I really want to know that everything's nicely dissolved and the borax is not going to get all volatile on me. So I've turned the heat off now. I'll put a little bit more cold water in. I don't need it to get too hot. Right, so that can sit on its own while we move on to preparing our sample plate for patination. Right, one thing I should say, it's really important that you keep your copper pot clean. Your RockShow solution, as long as it's not contaminated or overly dirty or got a dead rat in it, you can keep using it and adding to it. I've got solutions that I've been using for a couple of years even. When not in use, and if I know I'm going to be using this on and off over the course of a month, I'll simply keep a copper lid on it. Right? Alternatively, once it's cold, you can decant it into a plastic bottle or something. You don't want a metal lid because you don't want any corrosion from an iron or steel lid dropping into the solution, because that will contaminate it and ruin it. So, as I say, you need to keep the solution clean. But as we're working with it, we'll leave it as it is and move on to preparing our copper piece. And we'll talk about the materials I use for polishing and preparing. All right, so this is a copper plate. It's got some Shibuichi inlay. It's a partially completed exercise from a class. It's got a rough texture. It's got some smooth spots. And it's got two strips of silver inlaid. The silver is quite important to us because I maintain if you can patinate copper really well and get a good color in copper without the silver going yellow, then chances are you have a good understanding, good control of the patinating process. Right, so in these this copper salt type patination, there's often a tendency for chlorides, because there are salts of various types in the mixtures. Those chlorides combine with the silver and create a silver chloride layer on silver, and that causes a yellowish film. If you see the yellow film on silver, because silver is white and all silver and you can see it easily, it also means that that film is on your copper and it's on your shibuichi and everything. What that means is, once that happens, that the patina is not going to develop any further. So your copper patina will be stuck in a sort of an orangey, slightly orangey patina with a slightly yellowy, greeny overtone perhaps. Your shibuichi may have a slightly greenish, yellowish tinge. Shakido won't have the full black, and your silver, as I say, will have a yellowish tinge. And even your gold inlays will have a slight film on them. So it's really, really important to control this defect. In Japanese, it's called kabure, which means a rash. And we do this by adding a tiny pinch of alum. This is alum. And literally a pinch like that into the solution. I'm going to do 2 pinches in this instance. This is a deflocculant. So what that does is it combines with the chlorides and takes them out of solution, which helps control this tendency of silver and for these patterns to develop this yellow tinge. That's the main issue we face with trying to develop good patina. So having been armed with the alum solution, you should be able to at least have a chance of developing a nice clean patina. Be sparing with it though, there's no need to be heavy-handed with any of these processes. Now what we have here is, as I say, a piece that was used as a class sample. It's quite dirty and mucky. There's a reason I chose that one. I'm going to clean this, and I'm not going to clean it very well. And then I'm going to stick it in and let you see the kinds of problems that may occur. That's if I can make those problems occur. To show you the difference between a poor patina and a really good, solid, rich depth of color. You might be tempted, if you're a jeweler or have some experience with jewelry technique, to pop this in the pickle. I don't like to do that. There's a number of reasons. The main one being that although you'll remove all the oxides, you're then left with a thin film of broken down oxides on the surface. And while you may polish many of them away, you still get little pink residues in the recesses, which when you come to patinate, don't take a color. So I rather prefer to mechanically polish everything clean. I can also that way see where I still need to work, whereas had it gone in pickle, everything's nice and pink and clean, and it's very easy to get the false impression that the metal's are ready for patination. It's really crucial that the surface of the metal that goes into the patinating solution be completely fresh. By this I mean that an outer layer of molecules of metal and metal oxide has been completely stripped. It's for this reason I invariably will clean it as well as I can, patinate it until a color starts to develop, which will also then reveal any stains, any streaks or anything like that, and then I will go back and polish it once more. The second time always yields a better result. And what else to say? I think we'll proceed now with the polishing, and as we go along, I'll talk about any minor details. That way I'm not overwhelming you with too much all at once. Right, the polishing compounds I use, traditionally it would have been tonoko, which is a very finely ground fire clay. It has a very similar constituency, texture and grit to pumice. I use pumice now quite a lot. I like pumice. This is 120 grit pumice, and using a traditional Japanese horsehair brush. You can use a toothbrush or any other similar short, stiff bristled brush. with water as a slurry. Pumice will give you a matte finish. The other material I used to use quite a lot when I was doing restoration work was silicon carbide. This is silicon carbide powder. It's 600 grit. This cuts very quickly, very sharp, and it'll give you more of a shiny finish. What I sometimes do is I will use the pumice powder to clean and polish, and then I will take a little bit of the silicon carbide on my thumb and polish the high spots. So I've got a nice contrast of glossy and matte. A matte finish from the pumice will show the color really quite rich, whereas a glossy one will have more reflections, but it'll have more of a wet appearance. Of course, everything is waxed, so it's subtle differences in the final finished piece. Right, so I'm going to use the pumice first. So I'm dipping it in some clean water in the sink. And just for starters, I'm going to clean the back, because if there's any trace of grease or anything like that on the back, it may leach over and damage my patina. So just as a matter of course, I'll just gently go around and clean everything. And I go around the sides. It's really important to be very thorough. When you've spent a couple of days polishing a pair of large vases and tried to patinate them, only to find that you've got stains and little halos around the inlays, you very soon realize the value of getting it right in the first instance. Now you can see I've already cleaned the edges just by that light pass, but we'll carry on. Pop the piece down and a gentle circular motion. Change direction. Concentrate in one area at a time. Let the bristles do the work, rolling the little grains of abrasive around. A light touch means the bristles can really get into the nooks and crannies, which is where it's doing the work. I'll rinse it off here. So you can see, got a little bit of staining there. I think that's a bit of glue or pitch, but we'll keep on going. As I said, I'm not going to do this too much, so we'll do a rubbish patina first. You watch, it'll come out really well, and you'll think it's really easy. So what happens when you're working on a piece, you're handling it, your hands are greasy, you've perhaps had lunch, there's a trace of the pizza you had on your fingertips, all of that muck and oils and so forth, and just sweat works their way into the surface of the metal. So when you come to patinate, you clean it and it looks superficially clean, but perhaps it's not. So we'll call that clean, shall we? Now that's the first step. Before I put it in daikon, I use some carbon or charcoal powder mixed with bicarbonate of soda. Bicarbonate of soda, of course, is alkaline and degreasing, and the charcoal is a mild polish. And what it does is you can go around and you can see if there's no break in the water, there's evidently no greasiness on the piece. I'll do the back as well, make sure that's okay. All right. Right, so I'm just going to rinse that now, and then straight away out of the water into the daikon. I'm handling this just by touching the edges, so I don't want to get my mucky fingers all over the front, although as I'm working my hands are being degreased by all the polishing compounds. You find that after a day of patinating, your hands really do need some moisturizing cream or something. So the sample piece has been in the daikon for a couple of minutes. Again, to repeat, don't leave your piece in the Daikon and go for lunch and come back half an hour later or an hour later and expect it to be okay for patinating. There's a limit, I think, to how long the holding solution will keep things stable. So now I'm popping it in, and I literally just keep moving it around as I'm doing this. Now at this point, what I want to say is about polishing non-ferrous metals. When you polish a piece of metal and it's bright and clean and pink, you've just exposed fresh metal. And it looks like it's going to stay like that for some time, especially if you dry it and you put it aside. However, what your eye can't see is that almost immediately the oxygen in the air is reacting with that metal surface. So it's creating a film. If you were to polish a piece perfectly and dried it and left it aside on your work surface overnight and then came back the next morning and just popped it in the Daikon and tried to patinate it, you'll find that the patina simply won't take properly because you already now have an interference layer of natural oxides. So this is really, really, really important. I can't stress this enough. When you want to get a good patina, you literally have to polish your piece such that the tiny grains of abrasive, whether it's pumice or silicon carbide or charcoal powder, or whatever you're using, or even tonoko, mud, must be allowed to roll over the entire surface of the metal and slowly abrade away, like pebbles in the bottom of a riverbed, all of the layers of oxide that are there. This is the only way we can allow the Rock-Show solution to really have full access to the metal and develop a perfect layer of controlled patina of the type we really want. Now the patina on shakido, shibuichi, copper, even shinshu or Japanese brass, it's actually all the same stuff. It's cuprite. Under the microscope it's red, and so that's what's happening here. On the copper, of course, it's straightforward. It's just cuprite on its own. The different tones are due to the thickness of the layer of the patina and the size of the particles of the cuprite. On shibuichi, we've got cuprite with a little network of silver. The silver interferes with the light that's reflected back, and we see grey, various shades of grey. Over time, that silver network can tarnish and start to develop yellow colours, and then shibuichi can look a little bit green. Shakido, on the other hand, is copper, so it develops a red cuprite patina, but it has particles of gold in it, and the gold particles absorb the red spectrum of the light, and so our eyes perceive black. Shinshu, or brass, patinates to a lovely mustardy ochre colour. Again, this is cuprite, a nice red colour, but interspersed amongst the cuprite is zinc, and this zinc patinates to a zinc oxide, which is whitish, and that interferes with the wavelengths that our eyes would normally perceive, and we see instead the mustard ochre colour of shinshu or brass. And it's essentially these principles that apply to all of the irawe, or the coloured metal patinas that we see on Japanese sword fittings. Now this is going rather slowly, but rather irritatingly. It's actually quite even, but we'll see how it goes in a moment, and I'll take it out and we can talk about what's developing. You'll notice I'm keeping the piece moving all of the time. It's on a framework, as you can see, so I want to move the piece so it doesn't sit anywhere on its own. If you do that, you'll find you'll have a nice little tartan pattern on the underside. Not so big a deal on a piece like this, but if it was a two-sided piece you were making, or a little box or so forth, or a tsuba even, and unless you were in the Highlands, you might not particularly want a tartan pattern in your patina. That'd be a thing, wouldn't it? Tartan patinated metal. Right, so the colours are developing quite opaque. I'm going to take it out now. It's nowhere near what we're looking for, but it's enough for me to talk to you about what we need really to achieve before we go back to develop a nice colour. So I'm going to take it out now, straight in to the cold water, rinse it about. And now I don't need to bother with the Dicom because I am going to polish it again. So I'm going to dry it, and then we can talk about what we've got. Well, we are. Right, so here it is. I've just rinsed it off and dried it. You'll notice there's some mottling here. Now, I deliberately didn't polish that area very thoroughly. So what you see there are traces of the natural patina that had built up just from handling and so forth. If we were to carry on and a good patina were to develop where I had properly cleaned, this will never really catch up. It will always stand out as a dirty, smudgy area. These kind of things often happen around raised inlays, for example, where we tend to not spend enough time really getting into these little crevices and so forth. Sometimes before I begin proper patinating, polishing rather, I'll take a toothpick or a piece of bamboo chopstick that I've chopped up, and I'll polish just in the tip here with the powder or the silicon carbide or the pumice, whatever I'm doing. I'll go in around those areas, just working it, so I can really be sure that I've really thoroughly cleaned out those hard to reach little areas. You can see there's a bit of grayness developing on the Shibuichi already. It's not the best of colors. There is a hint of a patina developing on the copper. It's not very deep. There is around here, I don't know if it's visible, a bit of a petrol luster around the inlay. And there's some leftover pitch on the surface there, which I need to remove, probably by scraping. I think over here we can see a little bit of petrol luster. Now, when you see this petrol luster, and I hope you understand, you know, when you drop oil on the floor, engine oil or petrol at the petrol station, or gas, as you'd say in the United States, there's a sort of iridescence on the liquid. That's that petrol luster I'm talking about. So keep an eye out that if you do see petrol luster, in the early stages, yes, you will see some interference, because as the layer of patina is developing, it's very, very thin. You can still see through to the bare metal underneath. So there will be a sense of that. However, if once you've got an opaque color, a complete coloring of the metal, and you've still got iridescence, you've got a problem. And sometimes it's wise then to simply polishing everything off and start again. So you really have to keep an eye out for that iridescence. It's a problem. It's different from the kabure, that silver chloride film that has a tendency to develop. That's more noticeable because it is quite a strong yellow that appears on silver. And once you're familiar with it on silver, and you will see it at some point, you'll notice it when it happens on copper, because your patina will sort of stop at a sort of a yellowish orange color, and it just won't go any further. Those deep mahogany reds that are so desirable will simply not happen for you. Okay, so now I'm going to go back and really get stuck into some proper polishing on this one. And now I'm going to use a little bit of magnolia charcoal, Horn or Key. There's a similar charcoal, mesquite charcoal, certain pieces of it, in barbecue charcoal in the United States. I found some in a brand called Cowboy Brand, which amused me no end. But the trick is, if you can get hold of some magnolia charcoal from Japan, you then have a sample to try and then find local substitutes for. The same with the Scotch stone, really. It's a natural stone. There are bound to be other natural stones on the planet. We've just got to find them. And whoever does, I suppose, is going to corner the market. Right, so I'm going to run over the silver just very lightly with this charcoal. I don't want to work the patinas of the textures away. There's some little flat parts of the carving here. I'm just going to cover. Charcoal will really make sure I get rid of any old oxides. You can see it's really quite pink now. And let's just go in here. Charcoal is quite soft, so it readily adapts to the shape that I'm polishing. And the trick is to just work one bit at a time. You don't run across it, because that'll be like running cheese over a cheese grater, and all you'll do is chomp up your charcoal. Which, if you're importing it from Japan, probably not a good idea. Right, so we've got some nice clean, fresh metal exposed here. And this is really what we're after. We really want the metal nice and pristine, so that when we get it in the rock shell, it develops that perfect patina layer that we've controlled, and there's no unknown quantities in there. Textured grounds are quite tricky to patinate because they are, well, textured. And so there's lots of little nooks and crannies and little areas where dirt can get trapped, sweat can end up accumulating and so forth. So when developing a design, it's always good to bear these things in mind. Your final finish, of course, can make or break a piece. And if you've got, because of the surface finish, a real problem with patinating, you need to think about that ahead of time. Right, so I've done a little bit more prep work than I did the first time round. Now, there's a little bamboo handled brush. I've cut a little sliver at the end, and I'm going to dip it in water and pick up a little bit of pumice. I'm just going to work around the edge of the inlay. Like I said, sometimes it's necessary just to make sure that you've got in there. Because one of the things, if you've gone to all the trouble of doing very neat inlays, you really don't want the transition between the different colours of metal to be muddy or indistinct. In this instance, for example, although it's only a classroom test, it's a leaf, a ginkgo leaf, stylized ginkgo leaf, just for carving exercise, inlaid onto a stony ground. If this was an art piece, say, and it was a little leaf fallen on a pebble, we wouldn't want the leaf to look as though it was melting into the stone. We'd want it to look as though it literally had just dropped on it and was a separate thing. And that's, of course, the illusion. That's the illusion you want to maintain. So, in as much as the inlay transition, the joint between the shibuichi and the copper needs to be really neat and tidy, and you don't want a cushion of metal around the piece. So the colours must be nice and distinct. It's no good having a halo of dirty patina around the leaf. That's not going to look very convincing at all, really, unless you're trying to suggest mould and decay or something, which is an entirely different aesthetic. We'll call that the mucky school. The mucky muck school. So I'm just going around just to show you the kind of thing you can do. Let's say you can use a toothpick, you can use a little sliver of bamboo. It's just convenient that I have a little bamboo handled brush to hand. And I'm using the pumice because it will leave a nice matte finish. As I say, this is an exercise piece, it's not finished. Normally, this would all be cleaned up and then the texture would be worked in, so it would be an imperceptible join. But I've left the working marks. But you can see it's nice and clean around the inlay itself now. And now we're going to go and proceed with work just with the brush again. You remember there was a little mark of pitch over here. I've rubbed that off. Same trick, just with a little bit of silicon carbide on the back of the bamboo brush. Using the horsehair brush again. No need to make too much of a slurry. Just enough to keep it wet. You don't want dry powder floating around, getting up your nostrils and your lungs. And little circular motions, as I say, let the bristles get into the nooks and crannies. A little toothbrush will work as well. This is a Japanese horsehair toothbrush. It's a little softer. I could use that. You can go in at an angle, you see, so the bristles can really work in the corners. The trick is to work gently. Don't try and force it. It'll just force the bristles away from where you want them, and it'll wreck your brush all the quicker. I'm just going straight here because I want to clean in there. Then you can go back to a nice circular polishing motion. So you can just use a regular toothbrush for this as well. The only limitation, of course, with the toothbrush is the bristles are a little thick, so getting into those nooks and crannies will be tricky. If it's flat inlay, of course, it's much easier. You can polish your inlay up with various emery papers, and then just finish with a brush at the end, so that you don't have straight lines of a emery paper. Also, you can get a much softer finish with a brush because as you're polishing, I'm using the pumice here, so the pumice will break down itself. So it starts off at fairly large particles, and as you gently work along, they break down, become smaller, and a lighter touch means that your polish becomes ever finer. Is that awareness of materials becomes quite important as you become more expert, shall we say, in this technique. I'm going to go back to the horsehair brush. Too much. There you go. If you're tempted or intrigued to try the traditional Tonoko approach, this is a very fine powdered fire clay. Pottery suppliers will be able to supply you with something suitable. Tonoko is a buff coloured, tan coloured clay. And you can experiment with different grits. Again, because they're natural particles, they will break down as you're using them. And I dare say they're a lot cheaper than silicon carbide. I do use this stuff. Sometimes though, when you use it, initially, it looks like the metal's been scratched. Because of course it's showing up, every little mark. But as you proceed, you end up with a very beautiful, soft, gentle finish. It's just a matter of patience, really. If you've spent a couple of days doing your inlay work, half an hour polishing a little piece really isn't that much. And we're not going to spend half an hour polishing this, much to the relief of my camera lady. Because it's getting late now and it's getting noisy outside. And dark and cold. Right, so I think we might have a reasonably clean surface now. I'm going to rinse it off. It's useful to change the water as you're working, so that you've got a nice clean. You don't want to keep picking up dirt and contaminants and cross-contaminating your polishing compounds. If you move to a finer polish and you've still got traces of the coarser stuff, you'll be at it forever. Right, I think we're okay. And I'm going to put that aside. My handy custom-made box. I'm going to rinse off the block I'm working on. So that's nice and clean. Some fresh water. There we go. And now I'm going to go straight. Actually, I'm going to use a little bit of silicon carbide. Bring up a little bit of colour, brightness rather. So just to show you the difference, silicon carbide now. Okay, just a little bit. That'll do. I'm going to rinse this off. And a bit of clean water. All right. And then the final, before I put it in the daikon, is charcoal powder. Mix half and half charcoal powder and sodium bicarbonate. The sodium bicarbonate is naturally going to degrease. We have a nice little slurry. The carbon is a very gentle polishing compound, but between the two, they're thoroughly degreasing the metal now. If there was any grease, of course, we'd see little water breaks. As long as you don't see any water breaks, you can be sure that your metal's thoroughly degreased by this point. And go around the edge. Make sure there's no residue from my fingers. And a quick wipe on the back. This is messy work. Let's not wear white t-shirts or white anything really when you're doing this. And if you're going out for dinner, you might want to think about wearing gloves, because you're going to have black fingers for a day. But there's no shame in a working person's hands. So there we have it. And straight into the daikon. All right, it's still wet and I don't want to hang about. But that's nice and clean. And straight into daikon. Our copper sample plate with inlay has been in the daikon solution now for 3 or 4 minutes. I'm going to take it out, just holding the edge. I'm going to get my fingers all over it. Throw off the daikon. If daikon gets in the rock show, it's not the end of the world. It's not a big problem. You just fish it out later. It doesn't seem to have any negative effects. Just going to rinse it off in the water and then into the patinating solution. Now I'm going to move it around continually, and I'm really keeping a close eye on the development of the patina. It would be almost impossible to film this as it's developing. But what I'm watching for now is that as the metal very, very slightly starts to discolor, that it all happens evenly. I don't want to see any areas that are remaining bright, or stained areas, or little blotchy bits around the inlay, because what that tells me is that there's some grease there, some trapped dirt, or on these kind of textures that we did in class, one of the hammers we used did in fact have some loose rust on it, and there were tiny particles of rust that got pounded into a couple of pieces of the copper, and as a consequence, when we were patinating, there were little orange halos around a little spot that wouldn't take any color. And it was only when we identified the culprit as being a tiny speck of rust, we managed to pick it out and repolish it, that the problem went away. So these are the kind of things you need to keep an eye out for. Moving things, rolling the piece around in the tray, in the basket rather. You can just get a sense of the color developing. With this kind of, or this style of patinating, slow is always better. If your patina is developing too quickly, it will invariably rub off too easily or simply brush off. So less is more. Typically, a good shibuichi can develop in about 20-25 minutes. Shakido, 30 to 40 minutes for a really good deep shakido. Copper, anywhere from half an hour to 8 hours. And I'm not kidding. I've done a piece where I literally had to nurse it like this for 8 hours. But the end result was an incredible deep mahogany red. But it's a bit disappointing when people just assume you enameled it or maybe sprayed it with spray paint. But you know you achieved it, so that's all that matters.
What did you do? Just sit by it for 8 hours?
I did.
What did you think about?
How I could have made better choices in life. Well, what I did was, I used a chef's trick. Actually, Bob Kramer told me. He used to be a chef, actually, before he was a knife maker. And put the pot over to one side. So just 1 inch of the pot was on the ring. And so it creates a convection current, the liquid, sort of rolling around, rising where the heat is, going to the surface, moving across and dropping. And so it created a little current. You could, I suppose, make a little gadget that moved it constantly like that. No doubt somebody will make one now. I'll offer to buy one off them if they do. I'll promote it on the channel. The official Iron Brush Patinating Agitator jiggity arm. Right, so I've got a patina developing now. I don't know if you can see. It's developing an opaque color, but I can still see through the layer. It's not quite fully opaque yet. You see? I don't want to leave it out of the liquid for too long. Okay. And you might discern that subtle iridescence on the surface. At this point, I'm not worried about that because we're still building up an opaque layer. By opaque, I mean a layer that you can't see through. It's a true solid color on the surface of the metal. And remember what I said earlier on, the patina is the metal itself being converted to a layer of metal oxide, but a very, very thin one and very ordered, so that if the metal's polished and it has a crystal structure, the patina that develops will develop on each different crystal at a slightly different angle, so that you can see the crystal structure then in the patina. This is quite a sophisticated thing, and it's quite a delicate thing, and it should make it clear then why these kind of patinas are so much more exacting in developing them, as opposed to, say, slapping vinegar and copper sulfate on some brass or copper to get a green under the sea kind of look. Right, so the colour's getting more and more opaque now. There's still a bit of metallic hint in the copper, and the shibuichi for that matter, but you'll notice the silver is nice and clean still. So I'm not in any way worried about kabure, that yellow rash. And you'll notice around the inlay as well, there's no blotches, there's no stains. It's a very clean separation of colour. So at this point, I'm actually quite confident I could keep going, and the colours will only get richer and deeper and stronger. But there's no point trying to make the solutions a richer solution, because that will just cook things too fast. So the thing I'd like to point out here is also the copper has a nice fresh cleanness to it. There's no muckiness, there's no muddiness to it. There needs to be, how do I put this, a brightness to the patina. If it's muddy or murky or indistinct, it just feels dirty, then you know there's a problem with the metal, or your solution is not in the best of condition. More often than not, though, it is actually the metal surface. As I said, you need to make sure that the outer layer, that sort of outer micron layer of metal, is absolutely fresh and newly exposed, and has had no time to be contaminated with the air, and that it's only the Rockshore copper sulfate solution that's doing the work. We have a nice colour developing now. There's still a hint of metallic copper I can see through the patina. I see that as a slight pinkishness, and in some places a hint of petrol luster. But I know that because of the way things are developing, that the colour will be solid in a little while. It's always tempting to call it a day the moment you start to get colour, but if you're patient, those copper tones can really make your day, come out really rich and yummy. And as I say, a good patina on a piece really can make or break it. So the preparation and so forth to ensure that you get the best colours really is time well spent, especially if you've got all the trouble of designing something beautiful and you've spent days and days working on it. Rushing at the end is probably not going to serve you well. My own teacher demonstrated this technique to me on one occasion, and that was it. I then came home and got involved in restoration work, which meant I had to deal with all sorts of unknown metals and old metals, which really made me appreciate the need for very careful cleaning and really very acute awareness of the condition of the metal surface. And very gentle cleaning in preparation for redeveloping patina on antique pieces. As antique metal will take a patina very quickly because the surface has been actually very subtly corroded over time. Even if you can't see it, under a microscope, older metal is more open than the newly worked metal. And so consequently it will develop a patina quickly, but it will also pick up dirt very readily. The other problem with antique metal work is that, for example, a brass alloy, for instance, or may have a patina on it. If it's handled, that patina is now worn away, and taking with it zinc and copper. The zinc then is in the surface is now fresh zinc, and that will actually oxidize more readily than the copper itself, meaning that ultimately the brass will have less zinc in the surface. So if it's not carefully prepared, when you come to repatinate old brass tsuba and fittings, oftentimes the color is not that much different from copper. It takes some very gentle polishing and very careful consideration to try and get the balance of the alloy right in the surface, and to affect the original result, or to achieve the original patina result. Right, so what I've got is quite a nice orangey brown developing here. The Shibuichi is a commercial Shibuichi, actually. It's about 15% silver. I think this is a Phil Baldwin alloy. He was good enough to supply me with loads of the material for classes, pretty much at cost. So thanks, Phil, if you're watching. The copper, as you can see, is developing a nice orangey brown. There's a depth to it already that I'm very happy with. And you can see it's still glossy. There's a glossiness to the metal. It's not getting a dusty finish, so that I know that when it's dry and waxed, there'll be a nice rich luster to this piece. Now this hasn't taken an awfully long time, but the colour is now developing as it needs to. And we could cut back to this in 20 minutes, and I'll show you where we're at. You see it, that's a perfectly reasonable patina. I'm leaving it wet, so I don't want it to dry out. As I said, that could cause problems. You'll notice the silver is still very white. There's no staining showing up. There's a little bit of metallic luster up here, but that's just a matter of the metal developing fully. So there's just a few minutes later, not 20 minutes, so the colour hasn't changed much. Bella was just saying she really rather liked the slight petrol luster, pinkiness on the copper at the earlier stage, and she asked why that isn't something we work towards, and the simple answer is that it's not stable. It wouldn't stay like that. The patinas as they are now are pretty stable. They may deepen a little in time, but not massively so. As I say, the actual colour and the depth of colour, just speaking about just the copper in this instance, but it's true to a certain extent of the Shibuichi and Shinshu brass type alloys. But if we speak just of the copper, the actual colour and depth of the patina is dependent on the thickness of the cuprite layer and the size of the individual particles. And those are factors that are affected by the surface finish to a certain extent, the hardness of the metal, I believe, the extent to which it's been forged and worked, and perhaps even the purity of the metal. We know that, although it's taken as a given, rather, that the purer the copper, the better the red colour we can achieve. The tiniest amounts of trace elements in an alloy can change the behaviour of and the development of crystal structure. So it follows then that the tiniest change in composition of an alloy, and commercial coppers do have other elements in them, very small amounts. This will have an impact on the patina because the crystal structure itself is slightly different. We're talking about the way the particles of cuprite are arranged. When we have a cast piece of copper, you can see the crystal structure very clearly, a bit like crazy paving. And the reason you can see that is because each of those crystals, the arrangement of atoms is in a particular plane or in a particular direction. You have to think of it in a 3D sense. Now, if you're building up patina on those structures, you've just cut through them and polished them, and now you're going to build up patina on those structures. The cuprite particles are going to align themselves in relation to the crystalline structure of the metal. And so they basically mimic what's underneath, which is why a nicely patinated piece of copper that's cast, or Shinshu brass, and some of the bronzes, in fact, Sentoku being a classic one, has a very strong crystalline structure. These are all dependent on that internal structure, laying out almost like a blueprint for the structure of the cuprite. I'm going on about this because I hope it's helping you get an understanding of how the layer of colour builds up and the kind of things that will interfere with it. Of course, there's so many more details and aspects to consider, but they're all detailed in the book. There's some exciting things you can do with some of the brasses and the bronzes in terms of altering patina by forging prior to patination. Shibuichi has a number of clever tricks that can be applied, that one of which has been lost to the world. Well, not entirely lost. How's that for a little teaser? The so-called torafu, or tiger stripe Shibuichi. A little bit of cunning manipulation, and you can have stripy Shibuichi. The colour's developing very nicely now. We've got a deep terracotta, I'm quite satisfied with this. If this was a class situation and it was Friday and we're running over time, I'd call it quits. But because it's you, I shall stay here and develop a better colour. Right, I've got a very nice, very credible terracotta patina here. If this was on a Suba or Tosogu, it would be perfectly lovely and desirable. For the sake of instruction, I'm going to take it a little bit further. I'm going to take this out of the rock show, and I shall speak a little bit further now about the possibilities. And so I'm taking it out very quickly into the cold water. Now, just taking it on the edge. I don't want to leave it in the water. I'm going to put it, there we are. Put it in the daikon. Just temporarily. Now, this is a relatively neutral solution as it is. And it will develop the colors of Shakido to a good black, Shibuichi to a good gray. I wouldn't use brass in this solution with other alloys unless the brass was lower than 15% zinc. Anything over 15% zinc is going to cause a problem and cause staining with the other alloys. So that really is to be avoided. You can use brass with silver and gold, no problem. If you are doing that, use a separate Rockshore solution, preferably even in a separate dedicated copper pot. And what you can do to get the best results is double the amount of Rockshore. So if you're doing brass tap alloys on their own, you can double the amount of Rockshore. That's the only time I would recommend doubling anything or making a stronger solution. Now, with this solution as it is, if I wanted to push the terracotta further or ensure a rich orange terracotta color, I could put a tiny drop of vinegar in. It doesn't have to be rice vinegar, but if it makes you feel more oriental, rice vinegar is fine. Literally an eyedropper drop of vinegar in a pot like this. That's all. It's the very slightest push towards acidity. What I want in this case is to go more to the red. Now borax helps us do that. So I'm going to put a pinch of borax in, literally a pinch, like that. I shall put a little bit more, literally 2 pinches of borax. So, and I've pushed the solution just a little bit that way. I shall let it boil through. There are other ingredients we can add to affect things, but I don't want to talk about them in this film. I'll talk about more specific things in a follow-on. I don't want to clutter all of our thinking and what I'm presenting here. So I put a little bit more borax. I'm going to take a piece of copper, pop it back in the water, shake off the excess daikon and pop it in. Now let's hope it performs for you. So I've got a good leathery terracotta color here, orangey terracotta. Looks very Santa Fe. Oh, very, very warm. Now what I'm trying to do here is pull a little bit more redness into the patina. As I say, the best, deepest reddy browns are achieved over a very long period of time. But obviously you don't want to sit here watching me for 8 hours. And I'm sure you don't expect me to sit here for 8 hours and edit it down for 5 minutes. That would be so lazy. Well, it's been about 25 minutes since we last spoke. I've had a cup of tea, actually 2 cups of green tea. Because it's late and I'm feeling sleepy. I think the colours moved on adequately for you to see what happens just in half an hour. And hopefully I'll be able to show you in a moment a still from half an hour ago and now. And that you'll see how the colour's developing more of a red undertone. And that you can imagine how were we to leave this in for another half an hour, another hour, 3, 4, whatever, the color will keep moving in that direction, that sort of deep reddish mahogany color. So I'm going to take this out of the Nijiru solution and pop it into the water, cool it down. There we go. I can put this off. I'm going to put the lid on, not lose any more heat, and move this onto a clean piece of kitchen towel. Now I like to use kitchen towel because you only need to spend one day polishing a piece to patinate and then wipe it with a kitchen towel, with a tea towel that's got a bit of grit on it, to completely ruin all your work. So I use clean kitchen towel, and there we have it. Now I'm not going to finish this entirely now. For the purposes of this demonstration, I think this is far enough. What I normally do with patinating is I leave it overnight, or at least 24 hours, sometimes in the sun if there is any, but this is Brixham at the end of October, so your chance of seeing the sun is about as likely as seeing a Yeti. Right, so as I said, I'm going to leave this overnight at least, but there's possibly moisture underneath the inlay. That's often the case. So I'm going to warm it with a hot air gun now, with a piece of tissue ready to dab off any liquid as it comes out. And then I'll leave it overnight. Oh, there we go. I'm going to be careful because there may well be traces of the rock show in there. A bit more. Okay, so that's just a little bit too hot to touch. I'm reassured that there's no more moisture left underneath there. I'll leave it now. Just gives the pattern a chance to stabilize. The Japanese old masters would advise leaving it in the sunshine for a day or so. As I say, there's no chance of that here in Brixham this time of year. So I'm going to leave that for now, and that's the end of this particular segment. Next time I will go through the waxing procedure, but there's a little trick I shall apply to this that I've not demonstrated anywhere before, that really makes these things pop. You think of it as pushing the contrast. So with that teaser hanging there, I hope what I've shown and demonstrated thus far is of use. As I said at the outset, there are lots of little details, there are lots of tiny aspects that are really, everything's very important. Nothing is unimportant if you're trying to achieve a really good, clean, authentic, traditional type patina. And I would always suggest try to master these basics first. It's relatively easy to get metal to stain and tarnish and so forth. But if you're interested in doing complex inlay work and carving, you really do, the patina will benefit from being nice and clear and distinct.